Welcome to today's session. In this session, we are trying to understand NAT, also called as Network Address Translation. So, have you ever wondered how 100 devices in your home shares the single IP? How this is possible? How Google, who is the external entity seeing all your devices as a single IP, or if you are staying in an apartment with multiple people using the same ISP, how Google view them as a single IP? Means for Google they all belongs to single IP, means single user. Why do we have private IP and why do we have public IP? And why NAT is called as a biggest hack of IPv4? All these questions, these are actually a very good questions if we try to understand them. They are very interesting. So in this session, we will actually try to understand NAT and also try to understand all these questions answers. So let's start. So before starting, let's try to first understand why at first place we have NAT. We have initially said that we are using IPv4. Now IPv4 is 32-bit address. This we have seen. How many IPv4 addresses are available? 2 raised to power 32. It is around 4.3 billion addresses we have. Correct? But as of now, today, we have around 15 billion devices. Now, how 4.3 billion addresses sufficient for 15 billion addresses? It is not possible, right? It is not possible. So, how to make it work then? Because to access internet, we need the address. And if all 15 billion devices wanted to access internet, they should have 15 billion addresses, and that is not possible using IPv4. So how to make it work? So what happens is IETF, which is Internet Engineering Task Force, what they did is they came up with private IP ranges as a part of RFC 1918 exact. Okay. In this RFC 1918, they have drafted and they have declared that, or they have standardized that some of the IP ranges, for example 10.0.0.0 to 10.255.255.255, then the range starting from 172.0.0 to 172 dot something something, right? And one range starting from 192 dot and ending with 192.168.255.255. So these ranges are allocated or reserved for private IPs. So these addresses cannot be routed over internet. So you cannot access internet directly using these addresses. And boom, this change altogether fix the global shortage of IPv4 address. Now how this is fixed? This is still a half part of it. The another part, what IETF is they introduces NAT. Now what is your NAT? We will see it here. So now we will try to answer what is NAT, what it actually does. So what NAT actually does? So NAT rewrites the source or destination IP addresses in the packets and make the private networks to communicate to internet. That's what is NAT doing. So if I repeat, NAT translate the private IP, private source IP into the public IP address and eventually make them accessible to the internet. That's what it does. So for example, how it actually works is, let us say you are here, you are accessing something google.com for example on your laptop. You have a IP address like 192.168.0.203. This is your IP address. This is your private IP because it is in your home Wi-Fi. You are in your home network. Now this is coming in the private IP range, so you cannot directly access internet using this address. So what happens is, as soon as you access google.com, you put a request to access google.com, the request will go to the router. So router has a public IPv4 address which will be something like 49.207.55.19 for example. This is a public IP. So your router here itself act as a NAT device. So what it does actually is, request is coming from source 192.168.0.203. So the NAT replaces the source with 49.207.55.19, which is with public IP address, and then forward your request to the outside world. So you will be represented with this IP address henceforth, correct? Till the next hop you will be represented with this IPv4 address. So with every hop, right, there is a multiple hops we have seen in the middle. It's not a single router. There is a your ISP router present. Then you have a root servers. All these are middleman hops, right? Every hops does this address translation. Every hop has a NAT functionality. So it translates the address. So internet will only see you as a public IPv4 address. It will not see you as a 192.168.0.203. So this way, millions of devices in home, if you have a millions of devices, all these devices will have a different private IPs. Might be you have 100 devices or millions of devices, but all these devices will be represented with one single IP address externally, and with one single IP address they are accessing the internet. That's why the external entity sees all these devices as a single IP address or a single device. And one more concept which come here is port translation, port mapping. So what happens is, because multiple devices shares the same IP, then NAT needs something more to figure it out the request is coming from which device particularly. So what NAT does is, your IP 0.203, it will take it along with its port address. So if your port is as 150012, then router rewrites it, means router NAT rewrites it into 49.207.55.19.610023. This is a different port number, but the NAT device keep this mapping. so that when you request, you will be translated from here to here, and as soon as you got the response, right, you will be reverse translated to give you the response to the particular device and particular applications. That's how the port mapping comes for help. So then every NAT device maintain a NAT table, which is a interesting. How this table looks like is, so it looks like something like this. So you have a public IPv4 address. This is a NAT table. Okay. So you have a private IP, you have a protocol, and you have a timeout. So this is a NAT table. When you access internet, translation will happen from private IP to public IP, then access internet, correct? And when response comes, then public IP to private IP, and then give the response, correct? So this way the translation happens. Now one more question which actually comes, and which is actually in interview question. Why NAT breaks the incoming connection? Breaks incoming connection. Then this is a interview question. Why NAT actually breaks the incoming connection? So we have seen that when we have a laptop with IP which is a private IP 192 dot something, this IP is not routable over internet, correct? So if you directly try to access internet with this IP and you send your request to NAT, then NAT cannot forward your request to the global internet if it is coming up with 192 dot, which is a private range, correct? So it has to be translated to public IP address, then only the NAT can able to forward this request ahead, else it will not forward. So that's why if you will directly request with your private IPv4 address, then NAT will simply drop your request. It will not forward it ahead. To forward it ahead, you need to convert it into public IPv4 address. So that's why it is said that NAT breaks the incoming connection. Now, based on the purpose, right, we have a different types of NAT. Different types of NAT we have, and they are used as per the different purposes. So what are the different type of NATs we are having? First we have is a static NAT. So here basically what happens is private IP to public IP mapping will be done without port. This is important. It doesn't use the port. It works without port. So for example, it will be like 10.0.0.5. It will be translated to 203.0.113.0, 10 for example. So if you see, it is without a port number. So this kind of translation is done by static NAT devices. So where it is getting used? It is getting used in hosting public servers. Okay, if you have a public server, then it is getting used. Then CCTV. This kind of network translation is used. Second type of network translation which we have is a dynamic NAT. It is used inside enterprises. Okay, enterprises, then data centers, means organizations are using this more. Then ISP, this organization uses dynamic NAT. So what happens here is there will be multiple devices are accessing internet with the help of pool of IP, pool of public IP addresses, public IPv4 addresses. So that is your dynamic NAT. Okay. The third type of NAT which we have is a PAT, that is the port address translation. Okay, so this is a most commonly used, and even we are using it now. Means all your home routers, mobile hotspot uses PAT. So these are the three types of NAT which are present and used at different purposes. Now the next question which we have is, where does NAT lives? Is it the case that NAT is only present in the router? Then that is not correct. NAT is present at multiple hop. So as soon as the user access, there will be a router which is acting as a NAT device, correct? Then you will have a ISP router which will act another NAT device. Then you will have another router or server which will again have a NAT. So whatever multiple middlemen are there, all are using the NAT concept. Okay, so mostly home routers, then ISP using carrier grade NAT. We have seen this carrier grade NAT. Then firewalls, then cloud gateways. We have a AWS NAT gateway. If you would have heard it, AWS NAT gateway we have. So all cloud gateways uses NAT. Then Kubernetes. If you are using Docker container and all, then Kubernetes uses NAT. Then load balancers uses NAT. So all these concepts has a NAT. You need to configure the NAT to make these things work. So to quickly give you a overview of carrier grade NAT is, then we have seen, right, when we access internet via router, our router converts the private IP into public IP. But when our request goes to the ISP router, the ISP router converts. ISP router uses CNAT, that's the carrier grade NAT. So it works differently. It has a different way of translating the IP address. So it also do the translation, but it uses a carrier grade NAT just to separate the local NAT and the ISP level NAT. That's why it's a altogether different concept. One more myth which is most common, and it's again an interview question, is firewall, whatever we are using, is it equal to our NAT? Then the answer to this question is no, it's not. Firewall is not equals to NAT. If you are using firewall, you also need to use NAT. So basically, NAT hides your internal network, correct? So if your IP is with 192 dot something, the NAT will show it as 203 dot something. So nobody externally will got to know that your IP starts with 192, right? So one way the NAT hides your internal network altogether. So it has also some kind of security giving you, right? Now the last question which I want to cover is NAT with respect to NAT with respect to IPv6. So if you have gone through the series which we have, then you would have understood that IPv6 address is itself a globally unique address. Now, if we have IPv6 address, then we don't need NAT. If all our devices will start using IPv6, then the NAT concept will be altogether obsolete. It will become a concept of history. Because IPv6 address doesn't need NAT. you can directly communicate to the internet with IPv6 address. But the only problem with IPv6 is the adoption rate, right? The adoption of IPv6 is very slow, is slow. Still, we are using IPv4 much. We are not yet shifted to IPv6 yet. So once we shifted all our internet network to IPv6, then NAT is no longer needed. So this is all I wanted to cover in this session of NAT. So what all are things we have learned in this session? Let's try to recap it once. Okay. So you are in a private network, private LAN, you have a private IP. That IP will be converted with the help of NAT to public IP and access the internet. That's how the NAT plays the way. Then we have seen the different types of NAT. We have a static, dynamic, and PAT. We have three types. Then we have seen why NAT is called as it breaks the connection, incoming connection. Why it is called that it is breaking the connection, and why it is called as the biggest hack. Because we have seen, right, IPv4 only support 4.3 billion, but we have currently 15 billion. To make all 15 billion support, we need a NAT, and that's how NAT act as a hack for IPv4 address, and how IPv6 address doesn't need the NAT. All this concept we have seen in this today's session. If you like this video, do share, subscribe, and tell your friend about my channel. That will really help. So thank you.